Hello student, welcome all of you for the B.Sc. first year student. Subject is the paper is differential calculus, paper number first, semester first, lecture is 7th. Today we have to discuss one theorem, very important theorem. What is that? Statement of the theorem is every finitely derivable function is continuous. Every finitely derivable function is continuous. So we know that. What is meant by continuous function? So value of the function is equal to limit of function, then the function is said to be continuous. Value of function is equal to limit of function at that point is said to be the continuous function. What is the derivable function? If f dash of x is exist, then function is derivable. So this is the definition of derivability and the continuity. So we have to show that it is given that function is derivable and we have to show that the function is continuous. Let us start the proof. Let f of x be derivable for the x is equal to c. We assume that because it is given the function is derivable. So f of x be derivable for the x is equal to c, so that the expression this must be exist. Because function is derivable, and if function is derivable, so this condition must be satisfied. What is that? F of c plus h minus f of c divided by h tends to the finite limit as h tends to 0. Is it right? So this limit exists as h tends to 0, and that is nothing but f dash of c. Now we know that f of c plus h minus f of c, that means discriminant in codomain values f of c plus h and minus f of c, both belongings to the codomain, and we are taking their discriminant. So this term can be expressed as or can be written as, see here, f of c plus h minus f of c can be written as f of c plus h minus f of c divided by h into h. Taking limit on the both side as h tends to 0, we take limit as h tends to 0. F of c plus h minus f of c is equal to limit h tends to 0, f of c plus h minus f of c, h into h. So now here, if we separate the limit, this term and this term. So separating limit h tends to 0, f of c plus h minus f of c divided by h into, this is a single term, that is limit h tends to 0 into h. So value of this function, value of this term, limit h tends to 0, f of c plus h minus f of c divided by h. This is nothing but the derivative of that function at x is equal to c. So this is nothing but f dash of c, because this function is derivable. And function is derivable, therefore this limit is exist, and that limit is f dash of c is equal to 0. And the limit h tends to 0 of the limit h is h tends to 0, h goes to 0. So this is a 0. So f dash of c into 0 is equal to 0. So we get this limit h tends to 0, f of c plus h minus f of c is equal to 0. Now taking separate limit of these two terms, so here f of c is constant, so limit of f of c is f of c itself. And there is a variable h, so therefore limit h tends to 0, f of c plus h is something. But this is a constant term, and we transfer this constant term to the right hand side. To the right hand side there is a 0, and therefore we transfer this negative term to right hand side, so f of c. So limit h tends to 0, f of c plus h is equal to f of c. So this limit can be expressed as, replace this c plus h by x, replace this c plus h by x, isn't it? And as h tends to 0, c is nothing but x. As x tends to 0, c plus h replaced by x. So when h tends to 0, c is nothing but x, isn't it? So this h tends to 0, meaning is that c tends to, or x tends to c. So I can write this limit as limit f of x, x tends to c is equal to f dash of c. So here f was derivable function, f was derivable function at x is equal to c, and here we found that limit f of x, x tends to c is nothing but f of c, and this is a definition of continuity. Value of the function f of x as x tends to c is nothing but value of function at x is equal to c, that is f of c. So limit of function f of x as x tends to c is nothing but value of function at x is equal to c, and therefore the given function f is nothing but continuous function. So if function is derivable, then it must be continuous at that point. So every differentiable function is continuous. In next lecture we will discuss on its converse, meaning if the function is continuous, then what about its differentiability? Here we clear that if the function is differentiable, then it is continuous at that point. But what about the continuous function may or may not be differentiable? We discuss in next period. So this is very important theorem. You read it and do study of this. So thank you very much.